Hello, everyone. We are about to start section 6.2, and with section 6.2, that is going to be the law of cosines. The law of cosines. Now, if you remember from section 6.1, we studied the law of sines, and basically, the law of sines were used when we were given an angle side angle, an angle angle side, or a side side angle. Okay? Well, the law of cosines, what it's going to be used for, its main purpose is side angle side, and when given three sides. So basically, here's what the law of cosines looks like. If we have a triangle, and this angle is beta, this angle is alpha, this angle is gamma, then this side opposite would be B, this side opposite would be A, this side opposite would be C. So what the law of cosine says is it's going to allow us to solve for any side opposite the given angle. So, for instance, if we're given angle alpha, well, we can easily find side A using this law of cosine formula. Okay, so we can easily find it. If we are given side B, side C, and angle alpha, which means side B, side C, and angle alpha. So that would be an SAS problem. If we were given that, we could easily find the side opposite, which would be angle A, using this formula. Well, the same thing is true for side B, except for side B, we would need to know side A, side C, and we would need to know angle beta. And lastly, it's true for side C. So we would need to know A, we would need to know B, and we would also need to know angle gamma. Now, all three of these equations basically are going to be doing the same thing. And if you want to see a proof of these equations, the proof is too long for me to actually do on this video, but the one they give you in the book on page 366 is very nice and neat, and it's very easy to read as well. So, um, I would recommend you reading it so you have an understanding of how these formulas are derived, but not even in calculus do we derive these formulas by hand, okay? We just use them, okay? So I'm not going to make you derive them in this class as well. So let's look at the first case. Let's look at side angle side. That will be the first case that we're going to look at. And what I want you to realize is that we have some steps for this that are going to help you out. So for solving a side angle side case, okay, so we have step one. If you're trying to find a side opposite the given angle, if you're trying to find the side opposite the given angle, well, that is what a law of cosine is. That's what I just explained to you. So you're going to use the law of cosines, the law of cosines, to solve that. All right, well, if you're trying to find a second angle, if you're trying to find a second angle, well, there's a little catch to this. What you need to do is find the angle opposite, the shorter of the two given sides. The shorter of the two given sides. Okay? The reason why we do this is this angle will always be acute, meaning that when you type the inverse in the calculator, whatever answer you come up with in the calculator will be your answer. Because if you remember, when we do an inverse, we basically have two angles. We have um, whatever two angles give you the same sine value or the same cosine value. And generally, in some of these problems we've been doing, one of them has been acute, one of them has been obtuse. Well, if you choose the shorter of the two sides here, then you're going to have the acute angle, which is the angle you get in the calculator when you calculate it. So that just makes it very nice and neat. You can read your calculator that way and not worry about it. Now, what method are we going to use for this? Well, you can use either the law of sine or you can use the law of cosines. Either way, okay? There are going to be times when it's easier to use one or the other. Most of the time, a majority of the time, the law of sines is going to be the easiest to calculate, okay? So just keep that in mind. And number 3, if you're trying to find a third angle, this is where we subtract from 180. 180 minus other angles. And that gives us the third angle. Okay? 180 minus the other angles. Alright, so keep these in mind as we go through this. So let's look at an example. Alright, this is going to be a side angle side example. So here's our triangle. Okay, and we have this angle is going to be alpha. This angle is going to be gamma. This is angle beta, but we know angle beta is going to be 30 degrees, 20 minutes. Okay, so that's been given. We do not know side B, but we do know side A. Side A is 13.9 meters, and side C is 10.0 meters. 10.0 meters. All right, so we're going to solve this whole triangle. So I want to find B, alpha, and gamma. B, alpha, and gamma. Well, it's easy to find B. B is the side opposite our angle, and we have a side angle side here. So this is a law of cosines problem here to find B. So B squared equals A squared plus C squared minus 2AC cosine of beta. So this is going to be the square root of A squared plus C squared minus 2AC cosine beta to find side B. That's what we're wanting, is side B. So take the square root of both sides. So now it's just a matter of you plugging in, okay? So this is going to be 13.9 squared, 10.0 squared, minus 2 times 13.9 times 10.0 cosine of 34 degrees 20 minutes. Now this 34 degrees 20 minutes, you're probably, unless your calculator will do that, you're probably going to need to change it back to decimal degrees in order to make this work for you here. But if you do that correctly and take the square root and just do the arithmetic here, you should get 7.98 meters. Now remember, 3 significant digits because we have 3 significant digits here. Okay? Alright, so we know this is 7.98. 7.98. Alright, well, now we know all 3 sides. We know one other angle. So because of that, we can, to find one of the other angles, we can use the law of sines to find one of the other angles. So remember our goal. Look at our given. This is the smaller of the sides of the given. And this is side C, actually. And it's the smaller one. So since side C is smaller than side A, we're going to use side C. And that means we're going to try to find angle gamma up here. We know side C, we're going to try to find angle gamma. So why are we trying to do that? If you remember what I said, it's going to keep our answer acute. That way the answer you come up with in the calculator is the answer, okay? So it just makes it easier for you. So we have the sine of gamma over C equals the sine of beta, because we were given beta, over B. We've actually solved for B now. So it's going to be sine of gamma over 10.0 equals the sine of 34 degrees, 20 minutes, all over 7.98. Alright, so that's going to give us the sine of gamma equals 10.0 times the sine of 34 degrees. Again, you may need to change this back to decimal degrees if your calculator will not do this. All over 7.98. Now, how do we find angle gamma? We do the inverse sine, remember. So the inverse sine of 10 times the sine of 34 degrees, 20 minutes, all over 7.98. Alright, so punch that in your calculator, and once you change that back to decimal degrees, you're going to come out with 45.0 degrees. Which is the same thing as 45 degrees 0 minutes, since that's what we started out in. Okay, we started out in degrees, minutes, seconds. So 45 degrees 0 minutes. Make sure you change it back to degrees, minutes, seconds. Make sure you read the directions of your problem so that you can always make sure you have it in the right form. Alright, so we found side B. We found one of the two angles, one of the two remaining angles. So to get the third angle, we can subtract 45 degrees, the sum of 45 degrees 0 minutes plus 34 degrees 20 minutes from 180. And if you subtract that from 180, that will give you your final angle, which is alpha. So angle alpha equals 100 degrees 40 minutes. So you found all three of the remaining parts. There's one angle There's the other angle, and here's the side. Okay? So hopefully that makes sense. It's not difficult work. It's just a lot of little tedious things you can see in here. There's a lot of little places where you can make a careless mistake. Okay? Now remember, the reason we chose the smaller side angle, the smaller side and its angle to try to solve for here is so that we would get an acute angle here so that we could read it straight out of the calculator. Otherwise, you might get one that happens to be obtuse and the calculator reading will be wrong. Okay, so this will help you with your inverse sine if you just choose the smaller side like we did here. Okay, so this is the side angle side version. Alright, so let's look at side, side, side. So the last case is the side, side, side case. Alright, so we have some steps for solving it as well. If we're trying to find the angle opposite the longest side, find the angle opposite the longest side. This will take care of the obtuse. This will take care of an obtuse angle, so you won't have to worry about it. Okay? This will take care of an obtuse angle, so you won't have to worry about it. Step 2, either you can find either of the remaining angles. Find either of the remaining angles. Now, you can find either one because they're always acute. Since a triangle can have no more than one obtuse angle, these are going to always be acute. So that's why it doesn't matter which one you find first. You'll be able to use the calculator to read it, just like we talked about in the last one. And the last but not least, to find the third angle, we just subtract from 180. Now, one thing I haven't given you yet is the methods for solving these first two. Well, if I'm trying to find that side opposite, the angle opposite the longest side, I'm going to use the law of cosines. If I'm going to try to find either of these remaining angles, I can use the law of sine or cosine. Now, most people prefer the law of sine just because the computations are a little easier. Okay, so let's look at an example and make these make sense to you. All right, we have a triangular plot of land. Well, I'm doing a survey question. This is an application style question so that you can see this in application form. We have a triangular plot of land that we've surveyed, and we found that it has sides A equals 21.2 meters, side B equals 24.6 meters, and side C equals 12.0 meters. Okay, we want to find the measures of all the angles in decimal degrees. So find all angles in decimal degrees. Okay, so so the first thing I'm going to do is I'm going to look for the longest side. Well, that's side B. So because of that, I'm going to find angle beta first because that will be my obtuse angle if there is one. Okay, so I'm going to look for that first. So I'm going to use my law of cosines, which is this right here. and I'm going to use it to find angle B because I know all the sides. So this is going to be 24.6 squared equals 21.2 squared plus 12 squared minus 2 times 21.2 times 12 cosine beta. Alright, so solve this for cosine beta. Can't stand it when that happens. It deleted it. So solve that for cosine beta. So what we have 24.6 squared equals 21.2 squared plus 12 squared minus 2 times 21.2 times 12. Then need that extra 0 on the 12. Cosine beta times cosine beta. Alright, so we want to solve this for cosine beta. So cosine beta equals 24.6 squared minus 21.2 squared minus 12 squared all over 2 times 21.2 times 12. If you were to solve that for cosine beta, okay, I just subtracted these two off to get it on the side with this, and then divided, excuse me, this should be a negative 2, divided by this right here to get cosine beta by itself. Okay, so this is basically you punching it out in the calculator. So remember, keep it as accurate as you can. So in order to find beta, we're going to find the inverse cosine of all this. The inverse cosine of everything we have up here. And I would type it in. I know it's going to be a little bit more tedious to type in like this, but I would do this because it's going to keep you from making any rounding mistakes in your calculator, okay? Remember, if you round in the beginning of a problem like this, by the time we do all these operations to it, it makes a great deal of error in the end. So go ahead and punch that out, and it's going to give you the obtuse angle of 91.3 degrees. Okay, so that angle was obtuse. That's why we chose the longest side, so it would be obtuse. Remember, since it erased it, our sides are A equals 21.2, B equals 24.6, and C equals 12.0. Okay, so we found one angle. Now we need to find one of the other angles. Okay, now remember, it doesn't matter which one we choose, since since beta is obtuse, there can only be one obtuse angle, so the other two are going to be acute. That means when you type it in your calculator, you're going to get the correct angle with either one. So I'm going to arbitrarily choose alpha here, and because I like it better, I'm going to use the law of sines to solve this problem. Okay, so sine beta, now that we know beta, over B. So go ahead and plug in. So I have the sine of alpha all over 21.2 equals the sine of 91.3 degrees. Make sure your calculator's in degree form. All over 24.6. Alright, so we want to solve this for angle alpha, which if you do all the calculations, we're going to have to take the inverse sine of this, cross multiply, get sine alpha by itself, then do the inverse, just like we've done on many of these problems. So I'm skipping several steps here because I'm assuming that you're learning this because you're asking questions or not asking questions. So make sure that you are doing your following through and practicing these problems. This is the law of sine. We're just cross multiplying and dividing to get sine alpha by itself, and then we took the inverse sine to get alpha. Okay, hopefully that's familiar to you at this point. So that's going to give you alpha to be 59.5. Alright, so we have only one other angle left. So how are we going to solve it? We're going to get angle gamma by taking 180 and subtracting the sum of 91.3 plus 59.5. 59.5. And if you subtract that, you should get 29.2 for your answer. So here are our three angles that we saw for this particular problem. Three angles that we saw for this particular problem. So this is a side, side, side case problem. Okay, so we've done one of each now. Now let's do one more application problem. And it says this: a small plane is flying from Chicago to St. Louis, which is a distance from Chicago to St. Louis is a distance of 258 miles. After flying at 130 miles an hour, okay, for 45 minutes, the pilot finds that the plane is 12 degrees off course. 12 degrees off course. So, if she corrects the course and maintains speed and direction for the remainder of the flight, how much longer will the flight take? So we want to figure out how much longer the flight will take. So a direct route from St. Louis to Chicago to St. Louis is going to be 258 miles. However, she has varied 12 degrees off course. So what we want to know is, if she corrects her course and maintains her speed, how much longer will the flight take? So we need to know this distance so that we can figure out how much longer the flight will take. Well, we've got a side and an angle. Believe it or not, we can find this other side because of this little bit of information right here. Okay? If we take 130 miles per hour and 45 minutes is 3/4 of an hour. So if we multiply by 3/4 of an hour, that's going to give us 97.5 miles. 97.5 miles. So this is 97.5, that distance there. So notice what we have here. We have a side, an angle, and a side. And we're trying to find the side opposite that. So that's not going to be very hard to do. So using our law of cosines, if you think of this as alpha, beta, gamma and beta here, then what we actually are solving for is b squared, and we're substituting d in for b here. And so we have 97.5 squared plus 258 squared minus 2 times 97.5 times 258 cosine of 12, using our law of cosines. Okay, cosine of 12 degrees. And if we take the square root of each of those, if we take the square root of all that, that will give us D. So if you solve for D here, your D should come out to approximately 164 miles, since we're doing 3 significant digits. Now, the question says, how much longer will the flight take? How much longer? That's time, folks. How much longer? We have distance, but we can use that distance to get time. We can take that 164 miles, and if we divide it by 130 miles per hour that we have up here, we can get time. And if you do that, that ends up giving us approximately 1.3 hours, which is about 1 hour and 18 minutes. If you convert 0.3 hours back to minutes, 1 hour, 18 minutes. Okay, so here's a real life example of how we could use the law of cosines. So hopefully that makes sense. Hopefully the law of cosines made sense to you. It's a pretty quick section. We do have one other part of it on page 372. So if you'll get out your book on page 372, if you look at it, if you look, we've studied so far law of sine, law of cosine, but here's basically a summarization of solving triangles. It says, if you notice on page 372 in the green box, if you're given two angles in any side, you can subtract from 180 to find the third angle, and then use law of sines to find the sides. If you're given all three sides, use the law of cosines to find the largest angle. If you're given two sides in an angle, if one of the sides is opposite the angle, use the law of sines. If not, use the law of cosines. So on that page, page 372 in the green box, that's kind of your general strategy. I've read it to you. Don't memorize that, folks. Just kind of know in your mind how to apply it. Know what you're given, what you're looking for, and okay, if I'm given a side, an angle, and a side, and I'm looking for a side opposite, that's the law of cosines. If I'm given three sides, that has to be law of cosines. If I'm given an angle side or an angle side angle, that has to be law of sines. If I'm given a side angle, that has to be law of sines. So kind of get that in your mind as you're beginning to put these two things to use, because they're kind of doing the same thing. They're helping you solve triangles just two different ways. Alright, so section 6.3 will be coming soon. Have a good day.